Today we're going to be talking about deductive reasoning for section 2.4. Deductive or logical reasoning is a process used to verify conclusions. Examples of deductive reasoning are puzzles, games. When you play a video game, you are doing deductive reasoning. Your objective is not to end the game, whether you're trying to avoid being killed. So you must do certain things, and you learn stage by stage what to avoid, what to do, how to get to a certain place. That is deductive reasoning. You're figuring and connecting things as you go along in the game. Other examples of deductive reasoning are law or common law. Okay? Anything that is associated with our judicial system is deductive reasoning. So let's say you're a juror and you've been brought up to a case to find somebody guilty. Okay? And he might be guilty of murder. So they call you in. The job of the lawyer is to connect all these facts, all these statements. The facts are the statements. And they're trying to connect and piece together a story. Connect everything together so that you end up with a conclusion. Well, that's deductive reasoning. He breaks things apart, connects everything. Was he there the day of the murder? Was he there at exactly that time? Was there another way was the murder weapon there? Things like that. You're trying to connect things. So when you connect things to get to a conclusion, you're using deductive reasoning. Another example is Sherlock Holmes. If you ever seen his movies or you've seen shows that used to have a Sherlock Holmes or the book itself, Sherlock Holmes is deductive reasoning. That's where a lot of it came from. Not where it came from, but at least that's the point of the story. He was an expert at deductive reasoning. And really the beginnings of being a detective. Being able to solve things by putting pieces together. Knowing the facts. Can we put the facts together and figure out what happened? Find out the conclusion. Now, in geometry, there are two forms of formal logic. Okay, those formal logics for deductive reasoning are law of syllogism and law of detachment. What we're going to do in 2.4 is we're going to study these two forms or these two laws that are used for deductive reasoning. So the first thing we're going to look at is law of detachment. The law is if the hypothesis of a true conditional is true, then the conclusion is true. So this can be kind of confusing. The example says if P then Q, our conditional, is true, and P is true, where P is our hypothesis, then our conclusion Q is true. So when you look at this, it gets a little confusing. So before we even look at a problem, I made an example here. Okay? So the first thing is they have to give you two statements. I number them 1 and 2. The first statement is the conditional. If you are a math teacher, then you teach math. The first thing is the conditional is true. It has to be true. The second statement says Mr. Castro is a math teacher. Now let's teach how this law of detachment works. First, break down your conditional statement. If you are a math teacher, that right here is your hypothesis. So I have written it over here. Break down and find the conclusion. You teach math. So that's your conclusion. That's written right here. Now, look at the second statement. The second statement is Mr. Castro is a math teacher. That's what I've written down over here. The second statement matches the hypothesis of the given conditional. What does that mean? If this statement, Mr. Castro is a math teacher, is the same as the hypothesis of the conditional, and that means this right here, you are a math teacher. If these two statements are the same, then you can just repeat the conclusion, and that's going to be true. So therefore, by law of detachment, we can conclude that Mr. Castro okay, and now we put in the conclusion, teaches math. Okay, so let's go back to what you have to do. First thing is you need to be able to read your conditional statement and say that it's true. If you're a math teacher, then you teach math. That is true. Okay? Break it down into hypothesis and conclusion. You have to repeat the hypothesis again on the second statement, which is Mr. Castro is a math teacher. Notice how they both bring up the fact of being math teachers. So you're saying the same thing. Therefore, we can conclude that he teaches math. So Mr. Castro teaches math. Let's look at another example. Let's start with problem number 1 so you can see law of detachment once again. Okay, for problem 1, we're going to be using the law of detachment. What can you conclude from the given true statements? So each of these statements that is given for A, example B, and example C are true. The conditionals are true. So let's start with A. If the given says, if a student gets an A in the final exam, then the student will pass the course. The second statement says, Felicia got an A on her final exam. So the question is, does the second statement of the hypothesis, does the second statement match the hypothesis of the given conditional? So let's look at the second statement. The second statement says, Felicia got an A on her final exam. All you need to do is check the second statement and see if it talks about it in the hypothesis. So the hypothesis says a student, well, that happens to be Felicia, gets an A in the final exam. Felicia got an A in her final exam. So by law of detachment, we can conclude that Felicia will pass the course. Okay, that is because of the law of detachment. What we're saying is that once these two are the same, both the second statement and the hypothesis, therefore we can connect that statement, which is Felicia, that she will pass the course. Let's look at the second one on B. If a ray divides an angle into two congruent angles, so a ray that divides an angle into two congruent angles, that's what I care about right there. That's it. Then the ray is an angle bisector. RS, that's our second statement, divides angle ARB so that both angles ARS is congruent to SRB. So does the second statement match the hypothesis of the given conditional? In other words, are these two right here, the second statement and the hypothesis, do they mean the same thing? A ray. Well, this is a ray. RS is a ray because I can see that from the symbol. Divides, it does divide, both divide, an angle, the angles ARB, into two congruent angles. Those angles are ARS congruent to SRB. Both of them are angles. It is saying the same thing. So therefore, does the second statement match the hypothesis of the given conditional? That's a yes, as it was a yes for part A. Okay, the second statement did match. So both of these match. Therefore, by law of detachment, we can conclude that RS, our ray, which is right here, now we're going to connect our conclusion. The ray, which is RS, is an angle bisector. Alright, so that's what you're doing. You're using law of detachment. You just have to look at those two statements, the second statement and the hypothesis. Now let's look at the third one. For the third one, it says, if two angles are adjacent, that's my hypothesis. The second statement says, angles 1 and 2 share a common vertex. All you have to do is see if it means the same thing. Two angles are adjacent. Angles 1 and 2 share a common vertex. Unfortunately, adjacent and common vertex are not the same thing. So does the statement match with the hypothesis of the given conditional? In this example, you're going to say no. They do not match. If they don't match or mean the same or have the same meaning, then there is no conclusion. Therefore, we're just going to write no conclusion. Okay? So all you have to do is, are they the same? For number 1, they were. Number 2, they were. For number 3, they were not. Okay? All right, let's move on now to the next law, law of syllogism. For the law of syllogism, we are going to look at 2 statements, okay? 2 given statements. They're both if and then statements, so they're both conditional statements. If P and Q is a true statement, so if our conditional is true, and the second statement, Q, if Q then R, is also true. So they give you 2 conditional statements. If they are both true, then therefore we can kind of jump and connect P with R. And that can happen when we repeat the same Q, which in this case is our conclusion and then the hypothesis of the other statement. And once that happens, then we can connect those. So therefore it will be true. So let's look at this example right here. If it is July, then you are on summer vacation. So the first thing is, I'm going to highlight you are on summer vacation. Then the second statement, conditional statement, says if you are on summer vacation, then you work at a smoothie shop. So here's the thing, very simple. Okay, this one's easier to understand. If this statement, which in this case is our conclusion, and then it gets repeated again as a hypothesis, then what we can do is we're going to be able to connect the hypothesis of the first statement with the conclusion of the second statement. And that's what you conclude. If it is July, then you work at a smoothie on the shop. And that's what you're doing here. You're going to connect it as a new conditional. Okay, for problem 2, using the law of syllogism, what can you conclude from the given information? Okay, so here's the given. If a figure is a square, then the figure is a rectangle. The second statement says, if a figure is a rectangle, then the figure has 4 sides. So, the first thing you need to notice for is the conclusion. The figure is a rectangle. If it's repeated again on the second statement, and it's written as the hypothesis, as it's done right here, therefore we can connect we can use the law of syllogism and conclude the following. We're going to be able to connect that if a figure is a square, then the figure has 4 sides. In other words, we're connecting these 2 things right here. We're connecting the hypothesis of the first statement with the conclusion of the second statement. Okay, we're connecting those together. So therefore, by law of syllogism, we can conclude the following. Now we write it down. If a figure is a square, then the figure has 4 sides. So that would be our new statement by connecting those together. Now, the given says, if you do gymnastics, then you are flexible. So first thing is highlight the conclusion. If you do ballet, highlight the new hypothesis, then you are flexible. Notice that both what I highlighted in blue are not the same. Because they're not the same, and so therefore there is no conclusion. So there's our two examples of using law of detachment. This is it. This is the last problem for law of syllogism and 2.4 deductive reasoning. Go ahead and summarize your notes, and then if you have any questions, bring them up tomorrow when you're working on your assignment. Till then, bye.